Hi, my name is Sevinç Eroğlu and welcome to this talk on the design and evaluation of a freehand VR-based authoring environment for automated vehicle testing. VR is increasingly used for safe testing of automated vehicles. To create these testing environments, engineers typically use desktop-based authoring tools. However, this requires expert knowledge. Furthermore, to perform design modifications during the testing, the user has to leave the virtual environment. And this breaks the immersion and, more importantly, slows down the design and evaluation cycle. Scene authoring inside VR enables faster design iterations. And to this end, we propose an authoring environment to design road networks and traffic scenarios based on freehand interaction. To achieve a fast and efficient workflow, we devised a novel interaction technique for object placement and selection on a 2D panel. In this talk, I will focus on our proposed interaction technique, and please check our paper for more details about the authoring system. Designing a road network structure is a primarily 2D interaction task, and therefore, we design a scene control panel that consists of a 2D world in miniature. In our technique, the pointing ray is divided into colored sections that represent the different actions. Object placement and selection are triggered based on the distance of the index finger to the panel. Here you can see how objects are added into the scene, and the creation can be observed immediately in the environment. All created objects can be selected afterwards to be modified or removed from the scene. To evaluate our indirect technique, we performed a within-subject user study with 16 participants. Our goal is to provide a tool for road network authoring that is fast and offers a precise placement of objects. Therefore, we compared our indirect technique to a direct interaction technique regarding task completion time, precision, and usability. The direct interaction is inspired by the work of Code et al., where users create roads by placing control points directly on the terrain. And navigation is performed by using two-handed gestural inputs. We investigate the following hypotheses. Regarding task completion time, precision, and preference on road creation, we expect that indirect will outperform direct interactions. And based on previous works, we expect that direct interaction will be preferred for object placement. Regarding task completion time, the task is to add a sequence of control points onto predefined locations while being as fast as possible. To achieve this, both selection and navigations have to be performed. Regarding the precision task, participants were instructed to be as precise as possible for adding the control points without time restriction. In the direct condition, navigation is performed by using two-handed gestural input. It is enabled when the user performs a grab gesture with both hands. Moving the grab hands apart or closer, zoom in or out is executed respectively. Objects are added onto the terrain via the indicator that is attached to the index fingertip. Participants were instructed to be as fast as possible in the task completion time and precise as possible in the precision task. Based on the results, we found a significant difference in the task completion time, and indirect outperformed direct in terms of speed. Thus, we can accept our hypothesis 1. For task completion, we recorded the time that they spent on selection and navigation individually. And we observed that there is no significant difference between the selection techniques, while the travel technique in the direct condition significantly outperformed the technique in the direct condition. This result indicates that the overall task completion time is affected by the navigation rather than the selection technique. Concerning our hypothesis 2, we found a significant difference in terms of precision, so we can accept our hypothesis. Regarding hypotheses 3 and 4, a 7-point Likert scale subjective questionnaire was designed to be ranked after each of the conditions. And based on the results, indirect significantly outperformed direct regarding road creation and object placement. This confirms our hypothesis 3, but not 4. One possible reason is indicated by the qualitative feedback that we obtained during the study. Some participants found traveling by zooming with both hands to be less ergonomic than traveling via the 2D panel. In conclusion, we presented our system to create road networks and traffic scenarios based on freehand gestures. Furthermore, we devised a novel interaction technique to add and select objects on a 2D panel. To evaluate the performance of our interaction technique, we conducted a user study in which we compared our approach to an existing freehand interaction technique. The result showed that our indirect technique outperforms the direct interaction in terms of speed and precision, as well as usability and intuitiveness. We believe that our technique performed particularly well for this task since it addresses the 2D nature of the road network design problem. Thank you for listening.